Let's take a look at simplifying negative square roots. Whenever you have a negative under the square root, what you always need to do is replace the negative sign inside with an I outside. And the reason is that we decided that since we can't take the square root of negative 1, that the square root of negative 1 is going to be equal to this imaginary number. We're going to call this imaginary number I. So every time you see something that you could break down to have a square root of negative 1, we can replace it with I. For example, square root of negative 64 could be rewritten as the square root of negative 1 times the square root of positive 64. And as a result, we can pull that negative 1 under the square root into an I. It would be I times the square root of 64. The other thing is we know that root 64 actually simplifies down quite nicely to the number 8. So then you would get an 8 there, and you'd still have your I, so then this term would become 8I. Skipping a few steps here, we have negative 121. I know that I'm going to get a negative 1 under my root, and then my positive leftover is 121. The root 121 as a positive is equal to 11. The square root of negative 1 we know is just I. So it's going to just be 11I. And then this last one here, we break it down. Square root of 23. And 23, if you try to simplify that, factor that down, you'll find it actually has no other common factors. 23 is a prime number. And when it has no common factors, there's nothing you can do to rewrite or simplify this square root of 23. So one acceptable solution would be I times the square root of 23. Another related concept is finding something called the discriminant. So the key to the discriminant is using part of the quadratic equation. So you don't want to use the entire quadratic formula. You only want the part under the root, the b squared minus 4ac. And when you actually work that out, you won't even keep the square root around. It'll literally just be b squared minus 4ac, the part that used to be under the square root. So let's try some examples. Whenever you have something like this, we need to find our a, our b, and our c. So we could say our a is negative 2, our b is negative 8, and our c is negative 10. So we start working out this problem. We get negative, we only look at the discriminant part. We don't actually care about the rest of this, so don't get caught up in that. B squared minus 4ac, so negative 8 squared, make sure you keep your parentheses straight, negative 8 squared minus 4 times a, which is negative 2, times c, which is negative 10. So 8 squared is 64. If we add these up, we end up with a positive 20 times a negative 4, so negative 80. And we might recognize this from the earlier problem. But we end up with a discriminant of a negative 16. Now, when you're looking for a discriminant, there's often a second part to it. It says, how many real solutions do you have? Well, this negative 16, if you put it in the quadratic formula, would end up under a square root. And you can't take the square root of negative numbers, so there are no real solutions. And that's how you would answer something like this. You have no real solutions. In the next example, we have our a, b, and c just as before, and we want to figure out what is going to be the best thing we can do to determine how many solutions there are. And so if we start with our positive 1 as our a value, because there's nothing there. We have a 6 for our b value, and then we have a positive 9 for our value of c. So b squared is going to be 6 squared minus 4 times a, which is 1, times c, which is 9. So 6 squared is 36. 9 times 4 is 36. Times 1 is still 36. And there's a minus sign between them. So we found in this particular problem that our discriminant is equal to 0. And when the discriminant is equal to 0, that's kind of like this part of the quadratic equation ending up going away, going to 0. And if you do that, then this part here, this plus minus, also goes away, and really just your negative b over 2a is all that's left. So there's only one solution. So you only get one solution whenever you get 0 as your discriminant. And then finally this last one here, same idea with our x squared term. There's nothing out there, so a is equal to 1, b is equal to negative 2, c is equal to negative 3. And so b squared is negative 2 squared minus 4 times 1a times negative 3, another friend, which could be our c value. So negative 2 squared is 4. Negative 4 and negative 3 make positive 12. So we add them together, and times 1 is still 12. And that equals positive 16. So whenever you get a positive value, that's like taking the square root and getting a real answer and being able to plus or minus it. So we're going to get 2 real solutions. Real meaning no I involved. They're not imaginary. They're real solutions, real numbers.